Finding equations of perpendicular lines with Adam Maths Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Perpendicular lines are lines that intersect at a right angle of 90 degrees. The key rule is if two lines are perpendicular, the product of their gradients is -1. The general form for an equation of a line is y equals mx plus c, where m is the gradient or the slope, and c is the y-intercept where the line crosses the y-axis. If m represents the coefficient of x, I can use this to find the gradient of the line given. Y equals -3x plus 4 means my gradient is -3. As mentioned previously, if two lines are perpendicular, the product of their gradients is -1. So if -3 multiplied by my perpendicular gradient, which I can use this notation to represent, is equal to -1, then my perpendicular gradient can be found by dividing by -3 on both sides to give me -1 over -3, which simplifies to 1/3. The shortcut is to find what's called the negative reciprocal. So if I'm starting with a gradient of -3, the reciprocal flips the fraction upside down. So instead of being 3 over 1, it now becomes 1 over 3, and the negative of this will switch it from -3 to a positive third. Likewise, if I was working from 1/3 to find the negative reciprocal, I would flip the fraction upside down and change the sign to a negative, meaning my perpendicular gradient would be -3. Once the perpendicular gradient is known, I can substitute this into y equals mx plus c to give me y equals 1/3 of x plus c. I then need to substitute a coordinate that lies on the line using the corresponding x and y values. This has been provided in the question. When x is 6, y is equal to 1. Substituting my y value and making this equal to 1/3 of the corresponding x value, 6, plus c. Simplifying, 1 is equal to 1/3 of 6, which is 2, plus c, and subtracting 2 from both sides to leave me with c, which is -1. Lastly, I can rewrite the equation, substituting the now known value for the y-intercept, which is -1. My final answer, y is equal to 1/3 of x, take away 1. On to the next question. Find the equation of the line perpendicular to y equals 2/3 of x plus 4 and passes through the point -6, -4. Identify the original gradient. M is equal to 2/3. Since I know the line is perpendicular, I can find my perpendicular gradient using the negative reciprocal, flip the fraction upside down and change the sign, in this case to a negative. Substitute my gradient into y equals mx plus c. Substitute the x and y values of a coordinate that lies on the line. When x is equal to -6, y is equal to -4, and -4 is equal to -3 over 2 of the corresponding x value, -6, plus c. Simplifying, -4 is equal to 18 over 2 plus c. 18 over 2 is 9, and subtracting 9 from both sides to find c is equal to -13. Substitute into the original equation using the y-intercept that's just been found, so y equals -3 over 2x, take away 13. On to the intermediate questions with an increase in difficulty. For the first question, are the lines 4x minus y minus 5 equals 0 and x plus 4y plus 1 equals 0 perpendicular? The steps to determine if lines are perpendicular involve finding the gradients of both of the lines. I'll be able to do this a little bit easier if I change them into the format of y equals mx plus c. That involves isolating y by itself on one side and having everything else written on the other side. Starting with the first equation, 4x minus y minus 5 equals 0. The quickest way of isolating y by itself on one of the sides is by adding y to both sides. So on the left hand side, I'm left with 4x minus 5, and that's equal to y on the right hand side. I can switch the right hand side and the left hand side to have this written as y equals 4x minus 5. Moving on to the second equation, x plus 4y plus 1 equals 0. I can subtract x and 1 to isolate 4y. 4y is equal to -x minus 1, and then to isolate y, I can divide through by 4. Y is equal to -1 over 4x minus 1 over 4. If the two lines are perpendicular, the product of their gradients is equal to -1. Find the gradients using the coefficients of x when written in the form y equals mx plus c. One of the gradients is 4 and the other is -1/4. We can see that these are negative reciprocals of each other, but to prove it to the examiner, we need to multiply them to give me a result of negative 4 over 4, which simplifies to give me negative 1. Therefore, the lines are perpendicular. On to the second question. The point C has coordinates 2, negative 3, and the point D has coordinates 4, 6. Find the equation of the line perpendicular to CD and passing through the point D. If it's perpendicular to CD, I'll need to start by finding out what the gradient of CD is using the information provided. I can do this using the version of the change in y over change in x formula that looks at the difference between the x and y values of two coordinates, y1 minus y2 over x1 minus x2. It doesn't matter which coordinate I start with, as long as I stay consistent throughout. So if I start with the y value of negative 3 and subtract the other y value of 6, I need to stay consistent and use the corresponding x value to negative 3, which is 2, and take away the corresponding x value to 6, which was 4. Simplifying my numerator, negative 3 take away 6 is negative 9, and simplifying my denominator, 2 take away 4 is negative 2. Negative 9 over negative 2 is 9 over 2. Keeping this as a fraction will make it easier to find the negative reciprocal. Now I know the gradient of the line CD is 9 over 2. The perpendicular gradient will be the negative reciprocal, so flip the fraction upside down to become 2 over 9 and change the sign to a negative in this case. Now I know the gradient of the perpendicular line is negative 2 over 9. I can substitute this into y equals mx plus c. Substitute a coordinates x and y values that we know lies on the line to find the y-intercept. Since we know it passes through D, we'll have to use the coordinate for point D. When y was 6, this is equal to negative 2 over 9 of the corresponding x value, 4 plus c. Simplifying, 6 is equal to negative 8 over 9 plus c. Adding and subtracting fractions and whole numbers without a calculator will be made easier if I have common denominators. I can change 6 to be a fraction over 9 by timesing the numerator by 9. 6 multiplied by 9 is 54. 54 over 9 is equal to negative 8 over 9 plus c. Add 8 over 9 to both sides to find c. Therefore, c is equal to 62 over 9. Once the y-intercept is known, I can substitute back into y equals negative 2 over 9x plus 62 over 9, which is the known y-intercept. On to the advanced question, one of the trickier questions that you're likely to find on this topic. The straight line with equation 4x minus y equals 0 and the straight line with the equation 2x plus 3y minus 21 equals 0 intersect at point A. Firstly, we need to work out the coordinates of A. Finding the intersection will be a solution that satisfies both at the same time. I can do this by solving simultaneously. 4x minus y equals 0 can be rearranged to give me y equals 4x, and substituting y, which is equal to 4x, into the other equation will eliminate y. 2x plus 3y minus 21 equals 0. Replacing y for 4x eliminates y. Simplify. 2x plus 12x minus 21 equals 0. Simplifying further gives me 14x minus 21 is equal to 0. And solving to find x, 14x is equal to 21, which means that x is equal to 21 over 14, and simplifies to give me 3 over 2. Now I know x, I can substitute back into the original. Y is equal to 4 lots of x, so y is equal to 4 lots of 3 over 2, giving me 12 over 2, which simplifies to give me 6. So the coordinates of A, when x is 3 over 2, y is 6. For part B, work out the area of triangle AOB, where B is the point where line 2 meets the x-axis. You don't have to draw a sketch of how the two lines are interacting, but it might be quite useful in understanding what's required from the question. I know that this equation, written in the form of y equals mx plus c, is y equals 4x, and this one can be rearranged by taking away 2x from both sides and adding 21, and then dividing through by 3 to isolate y. So y would be equal to negative 2 over 3x plus 21 over 3, which is 7. Sketching how the lines interact with each other, y equals 4x would look something like this, and y equals negative 2 over 3x will be a lot shallower, going down from left to right, and go through the y-axis at the point 7. O is the origin, A is where they intersect, and B is the point where L2 meets the x-axis. We're required to find the area of AOB, which is this area highlighted on the diagram. This is a triangle that can be worked out using half the base times the perpendicular height. I already know the perpendicular height of this triangle. Since I've worked out the coordinate of A, this gives me my y value, which is the distance above the x-axis. So the height of the triangle is 6 units. So I just need to work out the base of the triangle, the length OB, and I can do this by finding where the line y equals negative 2/3 of x plus 7 crosses with the x-axis. The x-axis is described as y equals 0. So substituting when y is equal to 0, we'll find my corresponding value for x, which is where it crosses the x-axis. 0 is equal to negative 2/3 of x plus 7. Multiplying through by 3 to eliminate the denominator of the fraction. 0 is equal to negative 2 of x plus 21. Subtracting 21 from both sides leaves me with negative 21 is equal to negative 2x. And dividing through by negative 2 gives me a value for x of 21/2. From the origin to point B has been found to be 21/2, and therefore the area of the triangle can be found by doing a half of the base, 21/2, multiplied by the height of the triangle. This would be a half of 126/2. 126/2 is 63, and a half of 63 can be written as 63/2 to give me my final answer. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.